So we can have a quick look at solving some simple equations using function machines. This is just revision. It is just stuff that you have done last year, but bear with me anyway. So solving these one-step equations, first of all, using our function machines, we would start with x. X is our input. Then think about what's being done to x. Well, we're taking 7 away from x, so that would go in as our function, take away 7, and that is giving us the output of 53. Working backwards, we start with 53, change direction, and minus 7, add 7, because add 7 is the inverse of take away 7, and 53 add 7 is going to give us 60, so x is 60. If I look at this one, 3x equals 12. So 3x means 3 times x. So our input, because what we want to find out is going to be our input, is x. What's being done to it? We are multiplying it by 3, and that is giving us 12. Working backwards, I start with 12, change direction. The opposite of times by 3 is divide by 3, so 12 divided by 3 is going to give us 4, so x equals 4. This one, what's happening between x and the 5? Well, x is being divided by 5, and that gives us 3. So again, we start with x as our input. What's being done to it? We are dividing by 5, and that gives us 3. So working backwards, opposite of divide by 5 is times by 5, and 3 times by 5 is 15, so x equals to 15. We can use this method to solve slightly more complicated two-step equations. So if we start off again, we will start off with x. That is our input. That's what we want to find out. What's being done to x? 2x means 2 times x, so we are multiplying by 2. Then we are adding 3, and that gives us 13. Working backwards, we start with 13, change direction. Opposite of add 3 is take away 3. Opposite of times by 2 is divide by 2. So I got 13 minus 3 is going to give me 10, and 10 divided by 2 is going to give me 5. So x equals 5. Now, we can use the balancing method to solve this, and I expect some of you to have a go at this. So if I had 2x add 3 equals to 13, what I want to do is, at the end, I want to have x equals something. Okay, so I'm solving for x. That means I need to get x on its own on the one side. So I need to separate it from all the numbers. So the easiest thing for me to do here would be to take away 3. Okay, add 3, take away 3 is going to give me 0. It is the inverse action. But what I do to one side, I've got to do to the other side. So on this side, I'm left with 2x, and on this side, I've got 13, take away 3, so I've got 10. Then I think, okay, what's happening between the x and the 2 here? They're being multiplied, so the inverse of times by 2 is divide by 2, so I'm going to have to do that to both sides. What I do to one side, I do to the other. So I've got, that's going to cancel out. I'll have x left here, and 10 divided by 2 is 5. So you can use both methods. This one, we're going to go over the function machine method again very quickly. So I start with x because that's what I want to find out. What's being done to x there? Well, 5 times x, so x is being multiplied by 5, and then x is having 1 taken away, so minus 1, and that gives us 14. So 14, going in the opposite direction, the inverse of take 1 is add 1, and the inverse of multiply by 5 is divide by 5. So I'll end up with 14, add 1, which is 15, and 15 divided by 5 is going to give us 3, so x equals 3. We can use the same method again to solve the equation using our balancing method. So I've got 5x take away 1 equals to 14. I will start with adding 1 to both sides. So the inverse of take away 1 is add 1. Those two cancel out. I will end up with 5x on this side. But here I've got 14 add 1, which is 15. My next step, 5 times x. So the inverse of timesing by x is dividing by 5. So I'm going to divide 5 on both sides. I'll have x on the side. That cancels out. 15 divided by 5 is going to give us 3. So you can use both methods again.